Hey scholars, welcome to chapter 19.3, and we're looking at what can we do to actually slow climate change. We learned about what causes it, what it might look like in the future if it continues, but today we're going to look at what can we do to actually slow that change down. So dealing with climate change is pretty difficult because it's such a huge problem. You have a number of people live all over across the world and the planet, and we're all trying to work together, which is easier said than done, to fix this problem. So it's a global problem. It is a long-lasting effects problem, and it also is a long-term political problem, which is really where the global problem lies. Because there's so many people with different viewpoints and different opinions and different agendas, it can be very, very long and hard to get that done as far as politics goes. It is harmful and beneficial impacts of climate change unevenly spread. So some places, because of climate change, might see a better impact. They're going to have warmer climates other places that they normally wouldn't. So that's going to feel to people anyway better. It's also be harmful in some areas, which some areas will lose their human value because of the fact that their climate's changing as well. So that's another problem. And many proposed actions disrupt economies and lifestyles. And that's really what if you've ever seen the movie Day After Tomorrow, that is one, obviously, that we're in that movie they're talking about as a big panel, like, well, it's going to disrupt the economy, and our economy is just as important in the environment. And although that is pretty true, which one really plays a bigger role? And in my opinion, it's the environment, because if you don't have the environment, then your economy is going to suffer anyway. So because it does disrupt economies and lifestyles, people are very, very opposed to even doing anything about the climate change, or at least changing our habits anyway. What are our options? So we have two approaches. There are, number one, to drastically reduce the amount of greenhouse gases emissions that we're doing per year, since we've narrowed that down, it being the reason that the global climate is getting warmer. Devise strategies also to reduce the harmful effects of that global warming itself. And we're going to look at some of those strategies. Not necessarily all of them are good strategies, but they're at least strategies themselves, and they're thinking about it. The biggest question is, will we reach a political tipping point before we reach actually irreversible climate change, or at the tipping point of irreversible climate change, which is basically saying, are we going to get our poop in a group, as I like to say, our crap together, politically and government-wise, and do some changes and make some changes before we reach that point of no return with the climate change, where we really can't, the Earth won't rebound, it won't really even out at all. And some of you believe, we talked about in our case study, that maybe we already reached that point. Who knows? But that's the question. Will we reach the political tipping point where we're going to do something about it, politics-wise and government-wise, before we have a catastrophe going on with our climate? Avoiding catastrophe. What can we reduce, or we can reduce the climate change? How will we do it? Input some prevention strategies, preventive measures. Obviously, taking out greenhouse gases, stop emitting greenhouse gases. That would be a prevention strategy. Improve energy efficiency to reduce the fossil fuel use. That might kind of go into prevention strategy. Stop cutting down tropical forests, since that is a sink for carbon in a place where there's lots of photosynthesis occurring. And then output strategies would be like, okay, we know we're going to produce carbon, we need to keep it out of the atmosphere, so if we're producing it, where can we store it that keeps it out of the atmosphere? And we call that capture and store CO2. So we're going to take a look at some of these preventative measures. One of them is Sakalo and Pacala, and they actually came up with, it's on page 515 in your textbook, but climate stabilization wedges, which basically were strategies and pieces to the puzzle that would keep CO2 emissions to 2007 levels by 2057 levels. So one of those things, we know that we can't really go back and kind of just like turn everything around from where it was 50 years ago, but maybe we can at least keep it to where it's at around about now. If we can change what we're doing and meet those wedges, which we'll look at in a second, or maybe we don't, I don't know, we'll see. But take a look at page 515, and it does have that in there, the stabilization wedges. Oh no, I do have them, they're right here. Let's take a look at them real quick. Energy efficiency and conversion. If we met all of these standards with energy efficiency conversions, we would stick to that 2007 level, which would be good, because then we would at least be increasing the greenhouse gas any further. Renewable energy, increasing solar powered 700-fold to the pace. So if we do these things, we will be back on track. And that's kind of what they were saying with Sakalo and Pacala, that if we can follow this plan, we might be able to stop further climate change. And that's really what they were talking about there. Brown also says we need to actually do more than that. We need to not just reach the 2007 standards, but we need to even cut emissions even further. And that was one thing that he wanted to say. We need to cut it by 80% by 2020. And he wrote a book about that in 2008, the Plan B 3.0, Mobilizing to Save Civilization, which is just kind of an interesting title, first of all. So those are a couple of things that were like bigger viewpoints, wide scale. What do we need to do what are our goals? And these two groups of people, like Sakala and Brown, said we had differences in opinion, but both of them said we need to stop doing what we're doing now and see if we can work backwards and put ourselves back at where we were before. Output solutions. One of the output solutions is maybe massive global tree planting. Like in our last chapter, chapter 10, I believe it was, the Wangari Maathai. She was an African woman that actually mobilized women of Africa to plant many trees in Africa, and that was she actually won a Nobel Peace Prize for. But that's just one example of massive tree planting. China and Africa both have an idea to make great walls of trees, like the Great Wall of China, but really making a great wall of trees instead to again bring awareness as well as have some reduction of CO2 overall as carbon sinks. So those are just a couple of things there. So solutions. We have prevention. We have cut fossil fuel use, shift from coal to natural gas, improve energy efficiency, shift to renewable energy resources, transfer energy efficiency and renewable energy technologies into developing countries. That's where they're burning a lot of the fossil fuels anyway. As well as I don't want to place the blame, but China is a big one. Reduce deforestation, use more sustainable agriculture and forestry, limit urban sprawl, reduce poverty, and then if the overall thing, slow population growth. Really, cleanup measures are to remove CO2 from smokestacks from our industry, store or what we call sequester CO2 by planting trees, because that's what trees do. They are a great sink for CO2. And then sequester maybe CO2 deep underground. If we can store CO2 underneath the ground with no leaks, then at least it's trapped, it's not being in the atmosphere, it's not causing global warming. Maybe sequester CO2 in soil by using no-till cultivation and taking cropland out of production. If you do that, then your fields and your grasses grow and sequester that CO2 as well, and it's held in the ground as well. Maybe even sequester CO2 in the deep oceans if no leaks were allowed again. That might be another cleanup method if we can store it down somewhere deep in the ocean, use that as a sink. That might be one way. I don't know if that's the best way, but it's a way anyway. Repair leaky natural gas pipelines and facilities, and use animal feeds that reduce methane gas emissions from cows and belching and farting and things like that. So those are a couple of the preventative measures and also the input measures and the output measures. All right. And this just shows some of the output measures, methods of removing CO2. One of them is to sequester underneath the ocean, maybe even put it down into deep wells, and maybe even put it into spent oil and natural gas reservoirs. Send it out to the trees, the tree plantations, crop fields, and switchgrass fields. And those are a couple of the options there for us. Again, I don't know if they're all the best, and the best one really measures preventative measures more than the input measures rather than the output measures. So one of these is the output measures is a CCS, or a carbon capture and storage system. And is this the answer? I don't know if it is. This might be our only method, last-ditch effort anyway. But there are several problems with this approach. And what we just talked about, which is sequestering it by storing it and capturing it and placing it in places like the ocean, underneath the ground, things like that. So that's CCS. One of the problems is that power plants we don't have any power plants that are using this CCS. If we do, they're more expensive to build, and they're relatively non-existent because no one's really jumped on board with this idea just yet. It is unproven as far as like if you store it, will it leak? Will it explode? What's going to happen to it? Is it going to hold it long term, or is it eventually going to leach out into the soil and make its way back to the atmosphere because it is a gas? We don't know. Large inputs of energy to work, and that just for this to work, we need to put energy in, which ends up still putting out CO2 in the process. So that's another issue with it as well. So those are a couple of the problems there. So should we use geoengineering schemes to help slow climate change, which is CCS? This is a crazy idea, but should we inject the sulfate particles straight into the stratosphere? Some people think it would have a cooling effect similar to when the volcano Mount Pinatubo that you guys watched in you looked at the core case study would have a cooling effect. Possibly that might also accelerate ozone depletion, which is another thing we're going to talk about in the next section of the chapter, because sulfate could do that. We don't know, so it's kind of an unproven thing, but that might be one way if we can inject basically pollutants into the stratosphere. Maybe it'll cool us. But again, remember what happened with the Mount Pinatubo. It just kind of rebounded anyway. So I'm not sure that's the right answer, but that's maybe one method of doing it. The problems with carbon capture and storage, again, just keep continuing. It promotes the use of coal. It doesn't really stop the use of coal and the production of CO2. It is the world's dirtiest fuel. Coal is. We'll get to that later next week. Effects of governmental subsidies and tax breaks. Again, how effective are those? And it also stores CO2 would have to remain sealed forever. No leaking. Because if there was leaking and it leaked out, we'd see that rebound effect again, like we saw after Mount Pinatubo. Should we use geoengineering schemes? Again, looking at it, should we remove the salt from seawater or HCl from seawater? That could have some major effects on the ecology when you change that. And something we looked, if you ever watched The Day After Tomorrow, that's what they think happened with that whole movie causing those big scary storms was the desalinization process. I don't know if that's the best way of doing it. Also, pump up nutrient-rich deep ocean water. This is one guy's idea. Scientist James Lovelock has suggested that we anchor huge vertical pipes in the sea as part of a system that would allow wave motion to pump nutrient water up from the deep ocean to fertilize algae on the ocean surface. He says that this resulting algal blooms would remove CO2 from the atmosphere and emit dimethyl sulfide, which would contribute to the formation of low clouds that would reflect the sunlight, make our atmosphere cooler. So that might be a possibility. Other people say we should re-ice the Arctic, where I think that's kind of crazy to think about. But what does it say? Let's see if I can find it here. Can't quite see it. But anyway, one of them was their ideas was literally to bring ice, like large chunks of ice. So here it goes. Other scientists to tow 8,000 ice-making barges to the Arctic each year to re-ice the Arctic. I don't know if that really, it doesn't sound really that good. That's a lot of energy spending to take ice back up there. But if any of those fixes fails, again, what about that rebound effect? If any of those things happens, it doesn't work, we could rebound and it still wouldn't work. How much would it cost to slow climate change? Again, the short-term costs of dealing with it now are a lot lower than trying to deal with it after the fact. It's always more expensive to deal with it after the fact, not only financially, but maybe even takes its hit on nature as well. So, but local economies, global economies may be boosted by this. Again, switching from energy resources from coal and gasoline and oil to something else might actually boost economies. It's a new industry, and there's lots of good things coming from that. Governments can't help reduce the threat of climate change. They can strictly regulate CO2 and methane emissions from power plants and pollutants. They can do this through what we call a cap and trade approach, which is basically saying like, hey, you have certain amounts of CO2 and CH4 that you can release in the atmosphere. If you don't release, if you make changes to your production habits and you don't release that many, you can then sell that to somebody else for money or trade it up and do it that way. So there's it's a kind of a using economics to better the environment with that cap and trade process. Increase subsidies to encourage the use of energy efficient energy, so give more money to companies that are doing better things to make their power plants more energy efficient and also pollutant efficient. And then technology transfer, again, changing that technology to better technology that is maybe less harmful in the environment. All right, so governments can enter into an international climate negotiations. We did this back in '97, even all the way through 2000. And this is, the 1997 was a treaty to slow climate change. And let's see if I can find it. It says in December 1997, more than 2,200 delegates from 161 nations met in Kyoto, Japan to negotiate a treaty to slow climate change. The first phase resulting in the Kyoto Protocol went into effect February 2005 with 174 of the world's 194 countries ratifying the agreement by mid-2008. Unfortunately, the United States was not one of those. It says it requires 36 participating developed countries to cut their emissions of CO2, CH4, and N2O to an average of at least 5.2% below their 1990 levels by 2012, which is where we're now. It says developing countries were excluded from having to reduce greenhouse gas emissions in the first phase because such reductions would curb their economic growth. In 2005, countries began negotiating a second phase that is supposed to go into effect after 2012. Let me give you the gist. Bush did not sign this agreement because of the fact that he withdrawn his participation in the Kyoto Protocol, arguing that it would harm the U.S. economy. He also didn't find it fair that the developed nations had to reduce theirs, and the developing didn't. So there was some problems with it as far as President Bush was concerned when this actually went into effect. So we did not sign it. We have still not signed it. So that's where we stand as far as the Kyoto Protocol. But a lot of countries have and are trying to stick to it. Some people believe we can move even beyond the Kyoto Protocol. And in 2004, Stewart and Weiner says there needs to be a new treaty made, and it should be led by the U.S. Since the U.S. has been the world's leader in CO2 methane emissions, we should be the ones that start it and really see it through. It should also include the developing countries, not just the developed countries. And also they think it should include cap and trade emissions programs and a 10-year goal, which would set up it would be stronger as far as a treaty goes. And it should be led by the U.S., seeing that we lead everything anyway, or not. And we kind of looked, as far as the Kyoto Protocol, looked like we backed away from this because we knew it would affect us a lot. It probably would have, but I think would it have been for the better as far as the environment goes? Yes, maybe not the economy though. Some governments are leading the way in this charge, and the Costa Rica is one of them. They actually want to be carbon neutral by 2030. Norway is on track to be carbon neutral by 2050. We know China and India must make energy changes in energy habits because they are burning a lot of coal, which is causing a lot of damage, which we'll talk about later when we get to air pollution. And U.S. cities and states are taking initiatives to reduce carbon emissions as well, especially California. California's probably been one of the biggest ones since they were pretty gross back in the day as far as air pollutants go. Use of energy efficient appliances in buildings have become kind of requirements, and there are incentives for consumers to use less energy as well. It says California has set increasingly higher standards for the energy efficiency of appliances and buildings, has created incentives for utilities to encourage consumers to use less power. This has helped slow CO2 emissions and save California from having to build 24 larger power plants. So they're doing some good things over in California as far as energy goes. Some companies are doing it as well as schools as far as universities go. And here's a list of companies, Alco, DuPont, IBM, Toyota, even Walmart. You wouldn't think so, but they're using fluorescent light bulbs and auxiliary power units on truck fleets to save energy as well. So there are some companies trying to reduce their carbon footprint. There are also colleges and universities trying to do this as well, like Oberlin College in Ohio is one of those. It says some colleges and universities are also trying to take action. Students and faculty at Oberlin College in Ohio have asked their board of trustees to reduce their college's CO2 emissions to 0 by 2020 by buying or producing renewable energy. So really making a push for renewable energy resources. There are also other universities like Yale as well doing some things. 25 different colleges in Pennsylvania trying to push towards renewable energy. So a lot of colleges are on track as well for that. We already looked at what our carbon footprint was earlier in the 6 weeks. You're more than welcome. The book gives you a number of resources on page 521 to go ahead and look through and see if any of those might give you a better estimate on where your biggest energy footprint lies. But what can you do to reduce CO2 emissions is drive fuel-efficient cars. Maybe walk, bike, carpool. Use energy-efficient windows and appliances and lights. I know the basic standard environmental science classes are doing what we call an energy audit. And we don't really have time. Maybe we'll have time to do this at the end of the semester. I need to get through some things first. But an energy audit would allow us to take a look at where are we losing the most energy as far as our windows, doors, walls, things like that. And what can we do to better those, and even our appliances. Heavily insulate your house and seal air leaks. Reduce garbage by recycling, reusing more items. Insulate your hot water heater. Use compact fluorescent light bulbs. Plant trees to shade your house during the summer. Set your water heater at more than 49 degrees Celsius or 120 degrees Fahrenheit. Wash your laundry in warm or cold water, so not hot water. And use low flow shower heads and byproducts that are close to you, so they're reducing their carbon footprint in transportation. So we can prepare for the harmful effects, though, because we know they're probably going to be coming. So one of the things we can do is reduce greenhouse gas emissions as much as possible. Move people from low-lying coastal areas, because we know they're going to be pretty impacted. Limit coastal building again. That kind of goes hand in hand with the second bullet. And then the fourth one there, remove hazardous material storage tanks away from the coast. So that's going to get blasted the most. Why put them in harm's way? Also, we could genetically engineer crops to be more tolerant to drought and hotter temperatures. Stockpile 1 to 5 years of key food items right now while we still can grow them. Waste less water and connect wildlife reserves with corridors. That way the organisms can, if there's something happen with global warming, they can move and go where they need to go without being in harm's way. And this just shows you in pictorial form of some of those things from this section. So that brings us to the end of chapter 19.3. Hope you guys enjoyed it. We'll see you guys for the last section, which is 19.4 on ozone layer. See you next time.